half-life of a reaction is the time in which initial concentration of the reactant is reduced to half of its initial value. At t is equal to 0, say suppose if we have concentration of the reactant as R0, then T half is the half-life of the reaction where this concentration will be R0 divided by 2. That's half of the initial concentration. Now let us find out what is the half-life for a zero order reaction. For a zero order reaction, its rate constant is given by K is equal to initial concentration minus concentration at a time t divided by t. When t is equal to t half, we have the concentration of reactant at that time interval is half of its initial concentration. So substituting this into the expression of rate constant, we can write rate constant at t half is K is equal to R0 minus R0 divided by 2 divided by T half. Rearranging this, I can write T half is equal to R0 divided by 2K. So this is the expression for half-life of a zero order reaction. So from this equation, clearly we can tell that half-life of a zero order reaction is directly proportional to the initial concentration of the reactant, and half-life of a zero order reaction is inversely proportional to the rate constant of the reaction K. In a similar way, how we have arrived at the T half for zero order reaction, now let us write it for first order reaction. We know that for a first order reaction, rate constant K is equal to 2.303 divided by T log R0 divided by R. So now when T is equal to T half, we have concentration of the reactant R is equal to R0 divided by 2. So therefore, rate constant K is equal to 2.303 divided by T half, which is equal to log R0 divided by R0 by 2. So here R0 and R0 gets cancelled, so which is equal to 2.303 divided by T half into log 2, and therefore K is equal to 2.303 divided by T half, log 2 is 0.3010, K is equal to 0.693 divided by T half. So this is the rate constant for half-life of a first order reaction. Rearranging this expression, I can write half-life for a first order reaction is 0.693 divided by rate constant K. From this expression, we can tell that half-life of a first order reaction is inversely proportional to the rate constant, and clearly we can see that half-life of a first order reaction is independent of the initial concentration of the reactant. T half is independent of initial concentration of the reactant R0.